All right, this is the next lesson in Unit 8. The lesson is called Key Parts of Polynomial Graphs. Okay, now we've just looked at key parts of graphs in general this year many times. Now we're going to focus on just polynomials. Okay, this lesson is 5 pages long. The first 2 pages should be review, and the last 3 pages will be new. Okay, so again, domain and range, in case you forgot, we've done this several times this year. The domain is a set of values of the independent variable. Typically, it's a set of x values. And recall that the range of a function is the complete set of all possible resulting values of the dependent variable after we have substituted the domain. Typically, this is a set of y values. Okay, range. So again, we're going to focus on polynomial graphs today. So example 1, state the domain and the range of each. So in example 1a, the domain will be the x values in this graph. Now this graph is going to keep going to the left forever, very slowly, but it's going to keep going to the left forever. And it's going to keep going to the right forever, very slowly. So the domain will be negative infinity to infinity. Always put parentheses next to infinities and negative infinities. And the smaller number always comes first. That's why I put negative infinity before infinity. The range is the y values in the graph. So this graph is going to go down forever. And it's going to go up forever. So the range will also be negative infinity to infinity. Example 1b, the domain, the x values, it's going to keep going to the left forever, the graph, and it's going to keep going to the right forever. So the domain, again, will be negative infinity to infinity. But the range starts at negative 15 and it goes up. It does not go below negative 15. So I put the smaller number first. The range is going from negative 15 up to infinity. Always put parentheses around the infinities. And if the negative 15 is included in the range, then you put this symbol. Okay? If the negative 15 was not included, so suppose it was like an asymptote, or if it was like an open circle, then you'd put a parenthesis. Okay, so that's the first page. That was domain and range. That should have been review. The second page should also be review. Increasing and decreasing intervals. Okay, so just remember, you're going left to right. You're reading left to right. So if the slope is positive, if it's increasing the graph, it looks like this. So this is an increasing interval. This is another increasing interval. If it's going up left to right, or if it's a positive slope. Okay? And the opposite, if it's going down from left to right, or it has a negative slope, it's a decreasing interval. Okay? So you can read through these if you'd like. We've gone through it a lot this year. And I always tell you to write down these 2 things. So whenever we do this, we use the x values. And you use parentheses. You probably remember writing this earlier in the year. Done it a few times. Okay, so state the increasing and decreasing intervals of the graph. So I'll do increasing in blue, okay? And you might be able, this might be a little hard to see, but this is where it's increasing, right there in blue. I'll just do the increasing in blue. And remember, you're going by, I don't know how well you can see that. Maybe I should use colored pencils instead. Let's break out. Let's see if you can see the colored pencils better. I don't know if you can see that very good on the video, but this is where it's increasing. So let me color in the x values that correspond to that. Should be right there. So -2 up to 1. It's decreasing everywhere else. Let me do that also. I'll do that in orange. Okay. This is where it's decreasing. Also over here. So let me color in those x values in orange. So the way you write that, remember, is you do negative infinity, going by the x values, see above, negative infinity up to -2. This symbol for union, and then again from 1 to infinity. Now let's do 2b. Where is it increasing? Again, let me do that in blue. I'll do that in blue again. Increasing right there. Again, I'm not sure how well you can see this in the video. Remember, I also post my completed note packets online, so it's increasing in those two regions. So let me color in the corresponding x values for those. So it's looking like about -1.5 up to 2. Just estimate that. -1.5 up to 2. Then again from 4 to infinity. Decreasing everywhere else. Let me do that in orange again. Decreasing right there. And then it's decreasing right here. You color in those corresponding x values on the x-axis. So I'll say negative infinity up to, remember, -1.5 about. Okay, I'm just estimating about -1.5. And then again from 2 to 4. Okay. Now we're going to do a turning point. Give me 1 second. All right, here we go. A turning point is where a graph changes from increasing to decreasing or from decreasing to increasing. A turning point corresponds to what's called a relative maximum or a relative minimum. We're going to do those in the next lesson, relative maximum and relative minimum. Okay, but now we're going to do turning points. Okay, so for example, this is a turning point because the graph is decreasing up to there, and then the graph starts increasing. So this is a turning point right there. This is also a turning point because up to now it's increasing, then it starts decreasing again. And this is another turning point because it's decreasing up to there, and then it starts increasing again. Now, a polynomial function of degree n has at most n minus 1 turning points and at most n x-intercepts. If a polynomial function has n distinct roots, meaning n different roots, then it has exactly n minus 1 turning points and exactly n x-intercepts. So for example, let's say I have this polynomial, x to the 4th power minus 3x cubed plus 2x squared minus 5x plus 6. That has a degree of 4. That means that the graph has a maximum of 3 turning points, because the degree is 4, and a maximum of 4 x-intercepts. That should make sense if you think about it. So let's think about it like this. Suppose we have y equals x. That has a degree of 1. So that graph looks like this. Okay, so since the degree is 1, it means there's 0 turning points. See how it never turns from increasing and decreasing, or vice versa? Because the degree is 1, so it has a maximum of 0 turning points. And it crosses the x-intercept once. Or think about it like this. Think about y equals x squared. That has a degree of 2, which means it has a maximum of 1 turning point. So look at it. See how it has 1 turning point right there? How about if we think about y equals x cubed? I'll do a more general one. I won't do x cubed exactly, but let me draw some cubic. Okay, so this is not actually x cubed, but it is another cubic one. But again, notice how it has a maximum of 2 turning points. One right there and one right there. Example 3, state the turning points of the graphs. 3a. Now it's a point, so you write it as an ordered pair, parentheses x comma y. So your turning point right there. You can estimate if you can't tell exactly what it is. And then we have a turning point right there. So I'm going to say negative 1, 4. And I'm going to say 2, negative 2. It might be a little bit past 2, but I'm just going to estimate 2, negative 2. Okay, so the turning points are, like I said, negative 1, 4, and it's a point, so as an ordered pair, parentheses x comma y, and then the other one is 2, negative 2. This next one is going to have 3 turning points. You got, this is 1 turning point. Another turning point over here. You got another turning point over here. I'm going to estimate, it looks like, I'll say negative 1.5, negative 2. Then you have 0, 4. And finally, it looks like 1.5, negative 2. Okay, so that's turning points. We'll talk about maximum and minimum next time. End behavior. We've done end behavior by looking at graphs, but now you're also going to have to do end behavior without graphs. Okay, so for any polynomial, there's 4 options for the end behavior. Zoom out a little bit. There's 4 options. Leading coefficient a is greater than 0. I'm just going to say that means it's positive, just to make it easier. Leading coefficient a is less than 0. I'm just going to say that's negative to make it easier. if the degree is odd and the leading coefficient is positive, the end behavior looks like this, okay? As x approaches infinity, it approaches positive infinity as well. P of x uses instead of f of x like we usually use, doesn't matter. And as x approaches negative infinity, the graph approaches negative infinity, okay? If the leading coefficient is positive and we have an even degree polynomial, the end behavior is going to look like this. If the leading coefficient is negative and we have an odd degree polynomial, the end behavior is going to look like this. And if the leading coefficient is negative and we have an even degree, then the end behavior looks like this. You should memorize these 4 basic graphs for the 4 general cases. And this is what the next example will be about. So if it's a little confusing right now, don't worry. We have an example on this coming up. Example 5, state the end behavior of the following function. So the 6 parts. A and B should be the easy ones, because we've done this a lot this year. So for example 4a, as x approaches negative infinity, I'll use f of x still. As x gets smaller and smaller, the graph is going down, so the graph is also approaching negative infinity. As x approaches positive infinity, the graph is going up, so the graph is also approaching positive infinity. Okay, these 2 should be review. The next 4 parts will not be review. That'll be new. So for example 4b, as x approaches negative infinity, the graph is also approaching negative infinity because it's going down. And as x approaches positive infinity, the graph once again is still approaching negative infinity because it's going down. Okay. The next 4 examples are going to be based off of the table on the previous page. Now we have 4 scenarios, okay? This one, this one, this one, or this one. Here's how you should do it. Example 4c. First figure out, is it even degree or odd degree? It's even because it's negative x to the 4th power, so it's even degree. And the leading coefficient, meaning the number in the beginning when it's in standard form, is a negative number. It's -1 for my leading coefficient. So I'm going to say negative leading coefficient. So think back to the previous page. And which of these 4 scenarios do we have? Even degree, negative leading coefficient is going to be this one down there. So if you have this shape memorized, I would just draw a quick sketch of that. That's what the end behavior is going to look like. And it's going down in each direction. So as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x also approaches positive infinity. Okay? And that's going to be true for any even degree negative leading coefficient. The next one. This one has odd degree because the degree is 5 and 5 is odd. The leading coefficient is +2. So I'm going to say positive leading coefficient. So think back to the previous page, which you should try to memorize. Which of these 4 is it? This one right here. So if you have this basic sketch memorized, I would just draw it right here. It's approaching positive infinity that way and negative infinity that way. Okay? So as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. Okay, that's true for any, that end behavior is true for any odd degree with a positive leading coefficient. Next one has even degree, but and a positive leading coefficient. So again, think back to the previous page. But the basic shape for this one's going to look like that. So as it's going towards positive infinity in each direction. Okay. And there's 4 possibilities. So this last one is the remaining one. This one has odd degree because it's in degree of 3. And a negative leading coefficient because it's negative 3. So if we think back to the previous page, it's the graph that looks like that. Draw a quick sketch to help you. And as x approaches negative infinity, you'll see the graph is going up and it's approaching positive infinity. And the other end, as x approaches positive infinity, f of x is approaching negative infinity. And that's the end of that lesson, okay? That lesson was called Key Parts of Polynomial Graphs.